Hello everyone and welcome to Proportions in the Right Triangle. Before we get started, it's very important that you understand the pieces of the right triangle. So given this right triangle right here, we have two legs, which would be this one, and we have a hypotenuse, which would in fact be the entire bottom portion, which is the one that is across from the right angle. So remember, the one that's across from the right angle is always the hypotenuse. In this picture, we also have two other things that's important for you to know. One of them is called the projection, which is the segment that the hypotenuse is broken into by the altitude. Technically, there are two projections in this case. There's this little projection here, and there's the big projection here. So they're both actually called projections. So we have the little one and the big one. And then the last piece that's important is the thing that's called the altitude. Obviously, we already know that the altitude is something that is in fact perpendicular to the base. So this green line is actually the altitude. Now, within special right triangles with altitudes, we have something that's called proportions in the right triangle that are important for you to know how to use. And they look like this. In this case, the picture forms similar triangles, and we have this thing called Pap, which is the projection over the altitude equals the altitude over the projection. So what's going to happen in a second is I'm going to give you some numbers. Let's say a number here, that this is 5, and that this is 2, and my altitude is x, and ask you to find x. So the way that we would do that is we would write a proportion based on the fact that the Pap proportion comes from projection over altitude equals altitude over projection. So seeing that, we would write 5 over x equals x over 2. When I cross multiply, I get x squared equals 10, and x is equal to radical 10. So keep in mind that one of the proportions that's formed from altitudes in the right triangle is what we call Pap. And with Pap, we are going to set up our proportion based on projection, which is this first one, over the altitude, which is this one here, equals the altitude again. And then this is the second projection. It's not the first one. And if you follow along the arrow, it's going to be projection over altitude equals altitude over projection. Just try and draw this in. This way, whenever I ask you to do another question like this, you know exactly how to fill it in. Now, for my lefties out there, you could technically go in the opposite direction. So if I wanted to start on the right here and go this way, it's also going to work. So watch this. It would in fact be 2 over x equals x over 5. And I wind up with x squared equals 10, and x is equal to radical 10 as well. So it doesn't matter which way you go, the Pap proportion is always going to work. Let's take a look at another example. So in this case, I have a dotted triangle here just to show you that technically, if this dotted triangle was in fact rotated and then dilated by a scale factor between 0 and 1, it would wind up to be this triangle here, the blue one. These triangles are in fact similar, so now we know the corresponding sides are in proportion. AD is equal to 6, I'm going to label that here. DB is equal to 24, I'm going to label that there. And it says find CD, so I'm going to label that with an X. If I was to do my Pap proportion, projection over altitude equals altitude over projection, I'm going to wind up with 6 over x equals x over 24. When I do the product of the means is equal to the product of the extremes, I get x squared equals 144. And since you all know your perfect squares, now we know x is equal to 12. And that's the solution for that one. Let's take a look at another one. So if I look at this picture, I will notice something that in fact the triangle looks as though it's upside down. I still need to label everything appropriately. It says EG is equal to 4 and EF is equal to 10. Now think about that for a second. If EF is equal to 10, I happen to know that GF, using the subtraction property, would in fact be equal to 6. If the entire thing is 10 and the first part is 4, then the other thing would have to be 6. Now let's also take a look. It's looking for DG, so I'm going to label that X. And this is again the Pap proportion. Projection, altitude, altitude, projection. Think about that for a second. Projection, altitude, altitude, projection. So it's labeled a little almost upside down, but I'm going to write 6 over X equals X over 4. Product of the means equals product of the extremes. Then I'm going to take the square root on both sides. And this is super important that you realize when I have the square root of 24, it has to actually get broken down into a perfect square and a non-perfect square. And my answer is 2 radical 6. So that is the Pap proportion. Projection over altitude equals altitude over projection. There's actually another proportion in special right triangles drawn with altitudes to the hypotenuse, and this is what we call the Hllp proportion. So it's going to be hypotenuse over leg equals leg over projection. Now this is rather interesting for several reasons. First of all, I'm going to do the hypotenuse over the leg equals the leg over the projection. And this is exactly how I would draw this in. It's the entire hypotenuse, which is this piece, over the leg equals the leg, the same leg, over the projection. In this case, it would be the one on the left. This also works on the right-hand side of the picture. So if I did hypotenuse over leg equals leg over projection. So think about that for a second. And that's why that note here on the bottom says you must use the same leg and the projection that's attached to that leg. So if I was trying to find the purple projection here, I need to use this leg. You would do the entire hypotenuse over the right leg equals the right leg over the right projection. Or if you were trying to find the other one, you would do the entire hypotenuse over the left leg equals the left leg over the left projection. So it could go either way, but you want to make sure that the projection is attached to the leg. So let's take a look at another example. So in this case, I have that AC, which is the entire thing, is equal to 9, BC is equal to 6, and it wants me to find CD, which is going to be this piece here. I'm going to do hypotenuse over leg equals leg over projection. So hypotenuse over leg equals leg over projection. It's going to be 9 over 6 equals 6 over x. When I do the product of the means equals the product of the extremes, I get 9x equals 36, and x is equal to 4. So in this case, CD would be equal to 4. Notice that in this case, I'm using the right projection with the right leg. So it's hypotenuse over leg equals leg over projection. If I was trying to find AD, let's say I had a y there, I would definitely need this piece of the triangle. Let's take a look at it. So in this case, it says if BC is equal to 10, so I'm going to label that 10, AC, which is the entire hypotenuse, is 25, and now it wants me to find AD. Now this is rather unfortunate because when I write my Hllp proportion, I need to use this piece. Unfortunately, I'm not able to use that piece because I don't have it. So you have to go and get it. So one of the things that you could do is you could either use the Pythagorean Theorem to come up with the length of AB, or if I wanted to, I could in fact change the question around and try and figure out what CD is so that I can use 10. That's the leg that goes with that projection. If the entire thing is 25, if AC is equal to 25 and AC is equal to AD plus DC, then what do you think CD is, or DC? It would in this case be 25 minus x. So this little blue part here is 25 minus x. Now I can write my proportion using the help. Hypotenuse, leg projection. So I'm going to do 25 over 10 equals 10 over 25 minus x. When I do the product of the extremes equals the product of the means, or the means equals the extremes, I'm going to do 25 times 25 minus x equals 10 times 10. And then I'm going to wind up with 625 minus 25x equals 100. I could minus 625 from both sides and get negative 25x equals negative 525. And then I can divide by negative 25. And x is going to be equal to 21. Think about that for a second. If this is in fact 21, then CD is going to be 4. Now it asked me for AD, so in this case, AD is going to be equal to 21. Again, hypotenuse, leg projection. Just keep in mind that we had to figure out that CD was equal to 25 minus x. And now on to the last example. It says, in right triangle RST, SW is an altitude, so please make sure you draw that appropriately. It says if WR is equal to 12 and WT is equal to 4, it wants you to find first TS. We'll do that first. A is TS. So think about that for a second. We're going to put an X here, and we're going to use hypotenuse, leg projection. So the hypotenuse is in fact 16 over x equals x over 4. I wind up with x squared equals 64, and x is equal to 8. Moving on to the next piece, it says SW. I'm going to put a y there for now. In this case, I'm going to use the Pap proportion. Projection, altitude, altitude, projection. Notice it's slightly different. It's like the first two examples. So I'm going to have 4 over y equals y over 12. When I do the product of the means equals the product of the extremes, I get y squared equals 48. I take the square root, and I have to simplify my radicals. So I wind up with 4 root 3. And then in blue, I'll do the last piece, which is SR. I'm going to call that Z. So in this case, I'm going to do hypotenuse, leg, other projection. So in this case, it's going to be 16 over Z equals Z over 12. When I do the product of the means equals the product of the extremes, I get Z squared equals 192. And then when I take the square root on both sides, I wind up with Z is equal to 64 and 3. So Z is actually equal to 8 root 3. This is a great example because we're doing all 3 proportions in the right triangle. The first one being the red one, which is hypotenuse, leg projection. The next one is, in fact, the black one, projection, altitude projection. And the last one is the other leg, so hypotenuse, leg projection. Okay, that's it, and I'll see you tomorrow. Thanks.